Hello everyone, this is Gopi Krishna, a final year student at SR University. Today I will be presenting my major project titled Design and Evaluation of an Accessible Early Cardiac Risk Warning System, which is done by me and my group of friends Navyalohita, Shivani, Chandu, Shravan and Vamshi Krishna under the guidance of Bediga Sharan Sir, Assistant Professor, School of CS and AI, SR University. Now, let me introduce my project. Cardiovascular diseases are one of the major causes of health problem worldwide. In many cases, heart-related issues develop slowly and do not show clear symptoms in early stages. Because of this, people often realize they have a heart problem only when condition becomes serious. Our project titled Design and Evaluation of an Accessible Early Cardiac Risk Warning System aims to develop an intelligent system using machine learning to detect early signs of cardiac risk from health-related data. Our system focuses on early identification, awareness, and prevention to reduce the chances of severe heart conditions. So, let me tell you how did we identify these problems. Many heart diseases occur without noticeable symptoms in the beginning, making early detection difficult. Factors such as high blood pressure, high cholesterol, diabetes, smoking habits, and increasing age significantly increase the risk factors of cardiovascular diseases. But these factors are often ignored or not monitored regularly. Existing systems mainly provide predictions after symptoms appear and do not explain the reasons behind the risk or suggest prevention actions. These lack of early alerts, explainability, and preventive guidance makes it difficult for individuals to take timely steps to protect their heart health. This is the main reason behind we choosing this project. So the main objectives behind of us is to develop a machine learning based system for early prediction of cardiac risk using health related data to classify cardiac levels into low and high categories, to generate early warnings to support timely prevention and medical intervention, to incorporate explainable artificial intelligence techniques like LIME and CHAP to explain predictions and identify key health factors, including influencing cardiac risk. So, and to provide counterfactual preventive guidelines and risk progression simulation to suggest health changes that may reduce future risk. These are the key objectives of a project. So coming to project analysis, we have chose as our project is a machine learning one, we have choose this Birmingham heart study, which consists of features such as age, sex, gender, e-smoking, cigarettes per day, BP meds, prevalent stroke, prevalent high, diabetes, total cholesterol, cis BP, dia-BP, BMI, heart rate, glucose. And our target variable is a binary one, as we are going to predict either 0 or 1. The main intention behind is to predict whether a person is going to suffer from cardiac heart disease in the next 10 years. So if 1, that is if the output is 1, the person will develop a coronary heart disease within next 10 years, and if it's 0, the person will not develop CHD within next 10 years. So this is a methodology that we have done with. So we initially collected health related data from the data set I mentioned and pre-processed and clean collected data, applied multiple machine learning models and classified cardiac risk levels like low and medium, low and high. Explain predictions using XA techniques like Lyman CHAP, provide counterfactual preventive guidelines, simulate future cardiac risk progression, and display alerts and recommendation. So we made an interface for this. I'll show you at the end of this explanation. Coming to pre-processing techniques and feature engineering, as part of data pre-processing, we have handled the missing values. We have done feature categorization. We've done correlation analysis and feature removal, outlier treatment, class imbalance handling using smooth technique, encoding technique, and data scaling, that's standardization. So we have, as I mentioned, we have used multiple uh, machine learning models like logistic regression, support vector machines, KNN, decision tree, random forest, XGBoost, and light BGM. So in healthcare, missing a high risk patient is more dangerous than false prediction. So recall is more important. So we more than accuracy, we choose the recall in healthcare. So we have calculated different metrics as I mentioned here using multiple uh, machine learning models, out of which KNN gave us the best results. Next, coming to explainable AI, Lyman SHAP. So SHAP is Shapely Additive Explanation. So what does the SHAP do is it shows which feature influence the prediction, indicate whether they increase or decrease the risk. And LIME, that is local interpretable model agnostic explanation, explains prediction for a single data point, highlights key feature affecting the prediction. And why we have used this, it helps understand how, like, what are the features influencing in making decisions that would develop trust and transparency among the users. So next, as I mentioned, counterfactual guidance and risk progression. So if a person is at high risk, it suggests what input to change to reduce it to lower risk. And coming to risk progression, if a person is low in risk now, it shows how risk may change in future if condition remains the same or change. And what are the advantages of a project is helps in early detection, timely prevention, better decision making. We use explainable AI to show key factors that's affecting proactive healthcare, key risk factors, and future risk prediction. And this is the time in which we have done our project. It almost took us 3 months from development to deployment. This is our project timeline. And these are the links that our project holds. Like we have our code in GitHub and a dataset, blog, and LinkedIn. So before concluding my project, let me take you to the interface that we have developed. Yeah. This is an interface that we have developed using HTML and CSS in the front end. And in the backend I mentioned we have used Python. We have used KNN model to predict. And we have integrated both using Fast API. So this interface, it clearly shows predict cardiac risk with explainable AI, as we are going to explain which factors are affecting in what ways. So this is how our pipeline we have designed our interface. So it initially takes clinical data from the user that we the user have to input the give the input. Then input will be validated. We predict the output using KNN. We give the explanation using sharp and line, and at the end counterfactuals. So here we have also developed in such a way that at the end of the at end of this analysis, the user can also download his report from our website. So this is the website that we have developed. So if you want to check, if you want to go through our website, please follow the link in the description so that you can go through our website and test your uh, cardiac health. And now let me conclude what my project. So here we have developed a machine learning based system for cardiac health prediction and classified individual into risk categories for better understanding like low and high, generated early alerts for timely prevention, applied XAI to explain predictions and identify key factors, simulated future risk progression, provided preventive guidelines to reduce risk, supports proactive healthcare and better decision making. So in order to understand what we have done, one must have to go through our website. Because of the convenience of time, I'm not going through complete website because it's taking too much of time and I'm unable to upload the video in the social media platforms. So please go through our website to understand it in a more clear way. We have done a, a, a large amount of work to make things so clear. As I mentioned, we have used HTML and CSS for the interface, and backend we have used machine learning, that is Python. We have used Fast AI to integrate our both front end and backend. That's all with this. Thank you.